Okay, my math people. Let's see, a radian. So from that video that we watched there on Wikipedia, it's a pretty good video. Check it out if you want to know more, which nobody wants to know more. But anyway, right, if we took a radius of your circle and we laid that radius along the edge, right, so the arc length, that's called an arc length. And then we drew that back. So here we have an arc length. So this is your arc length, right? It's around the outside of your circle. That length there is the same as the radius. Then this is 1 radian angle. Okay, that's 1 radian angle. That's how we define a radian, is by when the arc length is the same as the radius. Okay, and it turns out that there is exactly 3.14 radians in 180 degrees. So pi radians equals 180 degrees, right? Those are your two different types of angle measures, degrees and radians. Okay, so all of our things are going to be some fraction or multiple of pi, right? That's how we're going to define a radian. But it doesn't have to have a pi. It could be 3. We could have 3 radians or 6.1 radians. So it does not always have to be a fraction of pi. But for our course, it's going to be. We're going to have a lot of things in terms of pi. So let's look at drawing some of these angles. So here we have an angle of pi over 4. Okay, pi over 4, which means we're going to chop our 180 degrees, right, which is pi. Pi and 180 are the same. Chop 180 into 4 parts. Okay, so if we chop 180 into 4 parts, how many degrees are each of those parts going to be? 45 degrees, because 180 divided by 4 is 45. So we're going to start, we always start our angles at the positive x-axis. So this is 0 degrees and 0 radians, right? The positive x-axis is our 0 line. And then our positive angles are going to go up. Okay, so if we start counting counterclockwise, we are moving in a positive angular direction. Okay, right, so if we go all the way up from 0 to this one, that's 90 degrees, right? That's positive 90 degrees by going in a counterclockwise direction. Now, if we start at 0 and come down, right, if we go clockwise, the same way as our American Western clocks do, then we have negative angles. So if we come down our unit circle until we get to here, that's negative 90 degrees. Okay, so if we have a positive angle, that means we're going counterclockwise around our circle. And if we have a negative angle, we're going clockwise around your circle, always starting from the positive x-axis. Okay, so back to as we were, chopping it into 4 parts. So here is one part, there's another part at 90, right? Here's another part at 135, and then our 4th part is at 180. Okay, so looking at the numerator, we only want to have 1 out of these pi over 4 segments. So our angle is going to look like this. Start at the x-axis, the positive x-axis, and then we're going to end here at pi over 4. So this is a pi over 4 radian angle measure right there. The reference angle is the angle formed with the x-axis. Okay, so depending on what quadrant we're in, we're going to have, talking about quadrants, remember the first quadrant is always the positive x, the positive y. That's the first quadrant. Our second quadrant is over here. Okay, it also goes counterclockwise, so quadrant number 2 is the top left. Quadrant number 3 is the lower left. And quadrant number 4 is the lower right side of your grid. Okay, moving on. 5 pi over 8. That means we're going to chop our unit circle into 8 parts. So we're going to chop 180 degrees into 8 parts. And when we do that, each one of these parts is going to be 22.5 degrees. So here's your 180, right? So there's, and if we chop that in half, right, so there's 2 parts. And then once again, we'll chop it into fourths, right? So that means it's in the middle of that one, the middle of the 90s. And then we're going to chop it one more time, right? Because half of 45 is 22.5. So we're chopping our half of a circle into 8 parts. Okay, we're looking at taking 5 out of these 8 slices. So we're just going to count starting at the positive x-axis. So our first angle is always formed here, our initial side. And then we're going to count up to 5. 1, 2, 3, 4, 5. So this is where we're going to end here. This is a 5 pi over 8 radian angle measure. So the reference angle is going to be what's left to get to the x-axis. The reference angle goes from where we are to your closest x-axis. Okay? So if this much is 5 pi over 8, how many more do we have to go to get to 180? That would be 3 pi over 8. So our reference angle is going to be 3 pi over 8. That's how much is left to get to your x-axis. Right? In this case, the negative x-axis, because we're in the second quadrant. Right? 5 pi over 8 is a second quadrant angle between 90 degrees and 180 degrees. Okay, 4 pi over 3 is our next one. So we're going to chop our 180 into 3 parts. So 180 divided by 3 is going to be 60 degrees. So we're going to put lines at every one of the 60 degrees on our circle. And we want 4 of these sections. So there's 1, 2, 3, 4 pi over 3 is going to be down here in the third quadrant. Right, so 4 pi over 3 is an angle greater than 180 degrees. 4 pi over 3 starts at 0, right, the positive x-axis, and it ends in the third quadrant. 4 60-degree angles, or 4 pi over 3 radian angles. Our reference angle in this case is going to be pi over 3, because I've gone one of these sections past 180 degrees. So our reference angle will always be less than 90, and it will always be positive. So here's our first negative angle. Remember, negative angles go down from the positive x-axis. And pi over 4 is once again 45 degrees, so we get 3 45-degree angles to get down there, 3 pi over 4. Okay, so this is our reference angle, always formed back to the x-axis, which is just pi over 4 units away from the x-axis. So always your reference angle will have the same denominator as your given angle will. Right? This one's over 4, that one's over 4. The other one was over 6, the other one was over 6. Okay? So there's a little something about angles, right? So we always use we usually use radians when we're talking about trig angle measures. Okay, our theta and our alpha and our beta. So now let's look at some unit circle things and start building that. Okay, so our discussion of the unit circle starts with a refresher about geometry and our 2 special right triangles. So we have 2 of them. One of them has a 30-degree angle, which means our other angle is 60. So this is a 30, 60, 90. And then our other special right triangle is a 45, 45, 90, also known as an isosceles right triangle. So from our geometry, we should know that if this is a 30-degree angle, then our opposite side is the shortest of our three legs. So in this case, the side opposite the 30 is your short side. And we should know that the hypotenuse for a 30, 60, 90 is always twice as long as the short leg. And then the long leg is the short leg times the square root of 3. Right? This is always the ratio between your three legs of a 30, 60, 90 triangle. Now over here for our isosceles, right, both of these are the same. Right? The legs of an isosceles right triangle are the same length. And according to our Pythagorean theorem, the hypotenuse is always that leg length times the square root of 2. So let's use that information as we build the first quadrant of your unit circle. Okay? So it's called the unit circle because each one of these points is 1 unit away from the origin. Right? So all of our points are 1 unit away, which is why it's called the unit circle. So in all of our triangles that we're going to make, so here's a triangle, all of these triangles will have a hypotenuse length of 1. Okay, 1 unit. So we have 3 things that we need to fill in. First of all, we have a degree. This is 0 degrees. Right, directly along the x-axis is 0 degrees. It's also 0 radians. And then we have a coordinate, an x part and a y part. So what is the coordinate of the point 1 unit away from our origin along the x-axis? 1, 0. 1 unit in the x, 0 units in the y. Okay? So we're going to fill out all these coordinate points. Right? These are points along our circle for specific angles. Now let's look at the vertical line. At 90, our positive y-axis is 90 degrees. 90 degrees is the positive y-axis. That's pi over 2, or half of pi radians. Right? Because pi is 180, 90 is half of 180, so 90 degrees is pi over 2. And the coordinate here is 0 in the x and 1 unit in the y. Okay, so that's how we start, is with our 1, 0 and our 0, 1. 0 degrees, 0 radians, and 90 degrees, pi over 2 radians. Now the rest of these points come from your special right triangles. So our first triangle is our 30-degree angle. Okay, so we have a 30-degree angle. If we do 180 divided by 30, that's 6. So our first radian angle is pi over 6. Okay, so we have 30 degrees or pi over 6 radians. And here we have our first 30, 60, 90 special right triangle. Okay, with a hypotenuse of 1, that means our short leg is the y side, right, the vertical side. The vertical side is always your y length, and the horizontal side is your x length. So for our 30, 60, 90, the x is going to be the long leg. So let's do some figuring out. Remember that the hypotenuse is always twice as long as the short leg. So if my hypotenuse is 1, what does that make the length of my short leg? It makes it 1/2. So we're going to write these all as a fraction. So because it's the short leg is the vertical side, the y coordinate of our first point is going to be 1/2. Now if you remember, the long leg is always the short leg times the square root of 3. So if my short leg is 1/2, 1/2 times the square root of 3 can be written as simply the square root of 3 divided by 2. Okay, our next angle is 45 degrees. Okay, and you see this yellow triangle here? That's our 45, 45, 90 degree triangle. So our angle is 45 degrees. And if we do 180 divided by 45, we get pi over 4. Right, that's 1/4 of our 180 degrees. So remember, we still have a hypotenuse of 1 because it's the unit circle, so all the hypotenuses are 1. And we calculated earlier that the hypotenuse was the leg times the square root of 3. The leg times the square root of 2. Right, so we want to figure out what x is. That's the side of our triangle. Okay, but what did we decide the hypotenuse was? The hypotenuse is 1. Yes? So if we want to solve this for x, it's just a matter of dividing by root 2. Okay, now we're going to do some fancy math here, and that's called rationalizing the denominator, because we don't want to have a radical in our denominator. So when we do that, we get 1 times root 2, which is root 2, and we get root 2 times root 2, which is normal 2, right? So we no longer have a radical in the denominator. We have a normal number. So this is the x value, right? That's the leg of my right triangle if it's a 45, 45, 90. So root 2 over 2 is the x coordinate. And since it's an isosceles right triangle, that means the y value is the same as the x value. So both of our points at 45 degrees or at pi over 4 are root 2 divided by 2. Our last angle is going to be our 60-degree angle. So remember, this is still a 30, 60, 90 triangle, but now your 30 degrees is in the top portion and your 60 degrees is in the bottom portion. So if we do 180 divided by 60, that's a denominator of 3. So our 60-degree angle is also better known as pi over 3 radians. Okay? So notice we still have that same triangle. It's a 30, 60, 90 triangle. But if our 30-degree angle is here, that means your short side is down here, right? The x value is now your short side. And what was the short leg of our 30, 60, 90 triangle? Well, it was 1/2, because the short leg is always half of the hypotenuse. And if our short leg is 1/2, then the long leg is root 3 over 2. Okay? So notice some of these things. This is what I want you to notice about our unit circle. Notice that the numbers switch. The 30 degrees was root 3 over 2, 1/2, and the 60 degrees is 1/2 and root 3 over 2, because they both came from a 30, 60, 90 triangle. Only one of them, the y value, was the short leg, and now the x value is the short leg. So their numbers switch. And then always at a 45 degrees, these will always have the same values, because it's an isosceles right triangle. Now look at the x values. Okay, as we go up our unit circle, what do you notice about your x values? They always decrease. This is 3, 2, 1, 0, right? And everything is divided by 2. So root 3 over 2, root 2 over 2, root 1 over 2, root 1 is just 1, and then of course 0. And what do you notice about the y terms? They increase, right? From 0 to 1 to 2 to 3. And then of course to 1, right? 4. 4 over 2, square root of 4 over 2 is 1. Okay? So we don't have to memorize the whole entire unit circle. Just memorize our pattern. Okay? And you'll be able to fill in any unit circle within 30 seconds. It's super easy to do once you memorize the pattern. Okay? And that's what I want you to do. So hopefully this helps. We'll build the rest of the unit circle later, but this is the first quadrant the most important quadrant.